Okay, so as I mentioned in the introduction, before we dive into analytical geometry itself, I'd like to cover some fundamental concepts of algebra. And in this video, I'm going to start out with the order of operations. Now, there are many different mathematical operations which we can use in an equation, and I'm sure you're familiar with most, if not all, of these. They are addition, indicated with a plus sign, subtraction, indicated with a minus sign. We have multiplication, indicated with a times sign. Division, which can be indicated with a divide sign, for example, A divided by B. It can also be represented as a fraction, as one expression over another expression, for example, A over B. So there are two different ways of writing division. We have powers, for example, x squared is x to the power of 2. X cubed is x to the power of 3. We also have roots, for example, the square root of x, or the cube root of x. And we also have parentheses, which are used to group parts of an expression together. Now, I'm sure that most of you are very comfortable with each of these operations taken independently. For example, as I just give myself a little bit more whiteboard space, if I was to, for example, ask you to evaluate 1 plus 1 equals, I am almost 100% certain that every single one of you out there would be able to immediately tell me that 1 plus 1 is equal to 2. Likewise, if I asked you to evaluate 2 times 3, what's that equal to? I'm sure that you know that the answer is 6. These are very, very basic equations, and they're only using a single operator. However, the situation gets a little more complicated if I was to start to combine these different operations in a single equation. For example, if I was to ask you to evaluate 2 plus 3 times 3 and tell me what that is equal to, well, how do we evaluate this equation? Is it not correct that we could take this equation and evaluate it in two different ways? For example, could we not say, okay, well, I'm going to take 2 and add it to 3 first, then I'm going to multiply it by 3, so 2 add 3 is 5, times 3 is 15. Or alternatively, I could say I'm going to take 3 multiplied by 3 first, I'm going to add 2 to the result of that, so that's 2 plus 9, and that gives us 11. So could we not approach that in two different ways? No, obviously we can't. Look, these results are different. One way gives us 15, the other way gives us 11. Now the equation 2 plus 3 times 3 needs to give us a single constant value. That means that one of these methods is correct, and one of these methods is incorrect. And that's where the order of operations comes in. They're a simple set of rules which state which operators we evaluate first before considering other operators. And they make an equation like this one above, the 2 plus 3 times 3, have a definite meaning. And thus they actually allow us to evaluate such equations to get the correct answer. So why do I believe that this topic is so important and useful? Why am I teaching you this topic on this DVD? Well, other than the immediately obvious fact that this topic is essential for understanding and working with algebraic equations, which we're going to be doing a lot of that in this DVD, it also has a direct correspondence to an idea, a topic called operator precedence when we're dealing with programming. So when we're programming, we're often working with equations that might use a variety of operators, for example, additions and multiplications and subtractions. And the compiler for the programming language that we're working in is going to have its own set of rules that define the order of operations for those various operators. It needs to know which order do we evaluate this in to get the same result each time for that equation. Now, in languages like C, C++, C#, Python, and Mel, for example, the mathematical operators are all evaluated in the exact same order as they would be in algebra. And this logically makes sense since algebra has been around for a lot longer than those programming languages have. So when the person came along and designed a compiler to compile these languages, they made the mathematical operators work in the same way as algebra. Thus, in this video, by covering the order of operations the way that algebra works, you're also going to be preparing yourself for operator precedence when programming in a large variety of languages. So we've already seen all of the operators we're dealing with in this video. If I scroll back up, we're going to be dealing with addition, subtraction, multiplication, division, powers, and parentheses. And we need some set of rules that's going to allow us to evaluate expressions that use a combination of these different operators. So the first rule, the most important operator, if you will, is going to be our parentheses. The first thing that we evaluate in any expression that combines all of these different operators are parentheses. And that's because they're used to group parts of an expression. They explicitly state that that part of an expression must be evaluated before any of the other parts of the expression outside those parentheses. Because they explicitly state this, we must evaluate them first. And we've seen this already without even realizing it. We've seen it because, as I explained, the two possible, even though we know that one of these is incorrect, the two possible ways of evaluating 2 plus 3 times 3, when I wanted to say that I was going to add 2 to 3 before we multiply by 3, I used parentheses to group the 2 and the 3 together. That's saying we add 2 to 3, we evaluate these parentheses first, and then we multiply by 3. Whereas in the other example, where I wanted to explicitly state that we multiply the 3 by 3 first, and then add that to 2, I use parentheses to group the 3 multiplied by 3. So parentheses are used to explicitly state which parts of an expression we're going to evaluate first, and we must evaluate those parentheses before evaluating anything outside of the parentheses. So our order of operations has parentheses as the first thing that we evaluate. After parentheses come our powers and our square roots, and we're going to collectively call those exponents. So for example, if I had an equation, let's say it had 4 multiplied by 2 squared, and I asked you to evaluate that, we must evaluate that power first, that exponent first. That means we take 2 squared and we evaluate that part of the equation before anything else. So 2 squared we know is 4, so that means that this is equal to 4 multiplied by 4, and that gives us 16. So this is the correct answer for 4 multiplied by 2 squared. We take the 2, we square it first, and then we multiply 4 by that. The wrong answer would be if we evaluated that multiplication first before our power. So again, this is the wrong answer. But if we were to do this the other way, if we were to say, well, 4 times 2 is 8, and then work out 8 squared, that's going to give us 64. This is the wrong value for 4 times 2 squared. 4 times 2 squared is 16, not 64. So we must evaluate our powers and our square roots first, and we can see an example that uses square roots. So let's say we had the square root of 9, and then we can add to that 16. What does this equal? Well, the square root of 9 is equal to plus or minus 3, and then we're going to add to that 16. What have I done here? I said that we must evaluate our exponents first. Root 9 is a square root, that is an exponent. We must evaluate this part of our expression before we evaluate that addition. So I've evaluated root of 9, that gives us plus or minus 3, and then we add that to 16. Now, hopefully you guys do have the background knowledge required to sort of follow me when I say that root 9 is equal to plus or minus 3. If you haven't ever seen a square root evaluated like that before, it's basically because there are 2 different values that we could multiply, we could square in order to get a value of plus 9. For example, if I was to take plus 3 multiplied by plus 3, now these pluses aren't additions, they're just indicating these 3's are a positive value. So if I was to take 3 multiplied by 3, we all know that that gives us a value of 9. However, I could also take negative 3 multiplied by negative 3, and that gives us a value of 9 as well. So because both 3 squared and minus 3 squared give us a value of 9, the square root of 9 has to be 3 or minus 3. We don't know which of these could be squared to give us that value of 9. So when we're dealing with situations like this where we're taking the root of a number, there are always two possible values, and that's going to be plus a value and minus a value. That's what this notation indicates. So that means we actually have two different ways we could evaluate this expression. We could take positive 3 and add 16 to it, so that equals 3 plus 16. Or we take minus 3 and add 16 to it. So that means root 9 plus 16 is either equal to 19 or it is equal to 13. So that's the correct way to evaluate it. The incorrect way, so let's just clear our screen and write the expression again. So root 9 plus 16 equals, the incorrect way would be to take that addition before our exponent. So if we were to add 9 to 16, that gives us 25. So if we were to say, well, this is actually equal to the root of 25, which is equal to plus or minus 5, that is the wrong answer, because we must evaluate our exponents before our other operations. Now, it is worth noting that the way that we note our expressions, the way that we write our expressions, we can have roots that encompass more than just a number. We can actually have roots that encompass an expression, and that's going to be noted by the top line of that root kind of acting like a roof over the expression that we are taking the root of. So for example, if I wanted to say that I have 9 plus 16, and then I want to take the root of all of that, you'd notice that the top of the square root acts as a roof over the entire expression we're taking the root of. And usually, just for clarification, we also have sort of a small lip on the end that comes back down to indicate that everything that is underneath this root between here is going to be evaluated first, and then we take the root of it. So if I was to have the root of 9 plus 16, and then, for example, add 5, again, we must evaluate our exponents before we evaluate our addition. So we must evaluate this guy before we evaluate the plus 5. But in order to evaluate this exponent, we need to evaluate the expression underneath it. That means we take 9 plus 16, that equals 25. We take the root of 25, and then we add 5 to it. That means we have plus or minus 5 plus 5. If we were to take plus 5 plus 5, that gives us 10. If we were to take minus 5 plus 5, that gives us 0. So we have two answers there. One is 10 and one is 0. So just looking back over what we've learned so far, we've seen we take our parentheses first, and after parentheses we take our exponents. Again, that's our powers and our roots. After exponents, we are then going to evaluate multiplication and division. And then finally, after multiplication and division, we're going to evaluate addition and subtraction. So if I was to go back to our earlier example all the way up here, what is 2 plus 3 times 3? Well, we can now see that we must evaluate multiplication and division before addition and subtraction. That means we must evaluate this multiplication before our addition. So if we're evaluating our multiplication first and then the addition, that shows us that the correct way to work this out was our second method, where we took 3 times 3 to give us 9, we added 2 and 9 together to give us 11. So the correct result of 2 plus 3 times 3 is 11, not 15. So this is wrong. Let's take a look at another example. I am going to need a new whiteboard for this, so let me bring up a new layer. There we go, fantastic. And let's take a look at an example that uses divisions and subtractions. So I'm going to say that if we had 6 divided by 2 minus 1, what does that equal? Well, again, we evaluate our multiplications and divisions before our addition and subtraction. So we are going to evaluate division here. So 6 divided by 2 is 3. And then our subtraction, 3 minus 1 is equal to 2. Now, multiplication and division have the same precedence as each other. We evaluate them at the same time. So in cases where an equation uses both operators and there are no parentheses to specify the order of operations explicitly, then we must work from left to right. That's really important. If we have combinations of multiplications and divisions in the same expression and there's no parentheses telling us which order we're going to be working in, we work from left to right. For example, if I had 20 divided by 5 and then multiply by 2, we work from left to right. So we're going to, working from left to right, encounter the division first and then the multiplication. So 20 divided by 5 is 4, and 4 times 2 is equal to 8. We would get the wrong value if we were to not work from left to right. If we were to instead evaluate the multiplication before the division, we're going to get the wrong answer. So if we're to evaluate that multiplication, 5 times 2 gives us 10. 20 divided by 10 we know is equal to 2. This is the wrong answer. We've seen the correct answer is 8. So if we were to evaluate it in the wrong order, we may well get the wrong answer. So it's always working from left to right. And addition and subtraction, they work in the same way. They both have the same precedence as each other. And again, we work from left to right. So for example, if I was to have 2 plus 3 minus 1 plus 4, we work from left to right. That means I'm going to hit this addition first, then the subtraction, and finally the addition on the right-hand side last. So 2 plus 3 is equal to 5, minus 1 plus 4. 5 minus 1 is 4, plus 4, which is equal to 8. And it really is that simple. You just need to remember parentheses first, then exponents, then multiplication and division, and finally addition and subtraction. And there's a simple mnemonic to remember the order of operations. So let me clear myself a little bit of space. And this mnemonic is PEMDAS. That's P-E-M-D-A-S. PEMDAS. And what does this stand for? Well, P stands for parentheses. E stands for our exponents. I'm actually going to write exponents here. And of course, that's our powers and our roots. So parentheses, exponents. The M stands for multiplication, the D for division. So MD is multiplication and division. And finally, AS is our addition and subtraction. So PEMDAS, parentheses, exponents, multiplication and division, addition and subtraction. There is another variation on this depending on which school you went to where you may have learnt this. There are sort of 2 common mnemonics that are used. So just in case you've encountered a different one, let me scroll down and cover that as well. The other one that you may be familiar with is BODMAS. It's the exact same thing, it just uses different words. So BODMAS, B-O-D-M-A-S. The B stands for brackets, which is just another way of saying parentheses. The O stands for orders, which is another way of saying exponents. Then we have DM for our division and multiplication, and AS for our addition and subtraction. You notice the D and the M are switched around compared to PEMDAS, which said multiplication and division, and BODMAS, which says division and multiplication. Again, they have the same precedence. It doesn't actually matter which order we put those into our mnemonic because they get evaluated at the same time. So whether you want to remember PEMDAS or whether you want to remember BODMAS, if you can remember one of those two devices, you're good to go, because this tells us explicitly the order in which we need to evaluate our expressions. So before I set some questions for you guys to work through on your own, I'd like us to tackle a more complicated example together. So I'm going to bring up another new layer. So new layer. And let's tackle a more complicated example together. So this example, we're going to evaluate 4 divided by 2 minus 1. And I'm going to multiply that by open parentheses 3 squared minus 1. So what does this equal? So we need to remember PEMDAS, parentheses, exponents, multiplication and division, and finally addition and subtraction. So parentheses first, that means we need to evaluate everything inside these parentheses before we do anything else. And that means we need to evaluate 3 squared minus 1. So what does 3 squared minus 1 equal? Well, again, if we were to think back to PEMDAS, we know parentheses, well, we don't have parentheses, exponents. We need to evaluate our exponents next, and we have a power, so we must evaluate this first. So 3 squared is equal to 9 minus 1, which is equal to 8. So we know that the value of everything inside these parentheses is 8. So we can replace that now. So we have 4 divided by 2 minus 1 times 8. And what does that equal? Let's scroll down a bit. There we go. So again, we need to use our mnemonic, PEMDAS, parentheses. Well, we don't have parentheses. Exponents. Well, we don't have any square roots, we don't have any powers, so we don't have any exponents. So next we have multiplication and division, and you'll notice we do have 2 of these. Now as it happens, they're actually separated by this subtraction, and what that means is in terms of the result of this equation, each of these operations are actually isolated from each other because they're separated by this subtraction. And what that means is we can actually evaluate these in either order. But if you weren't sure, the most, I guess, safe bet way to approach this is to always work from left to right. So we're doing our multiplications and our divisions next. So 4 divided by 2 gives us 2, minus our next multiplication or division is 1 multiplied by 8, which gives us 8. 2 minus 8, we can easily work that out. We know that that's giving us negative 6. And that is the answer for our entire expression. So you can see that once we have learnt the order of operations, it's actually very simple and very fast to solve these equations that combine all these multiple operations into what look like quite complicated equations. Very simple to evaluate. We just need to remember those simple rules that we learnt, which we combined into that mnemonic PEMDAS, parentheses, exponents, multiplication and division, and finally addition and subtraction. So hopefully you're all now comfortable with the order of operations. So let's put that knowledge to the test. I'm going to set a series of questions, and after setting each question, you're going to have the opportunity to pause the video and attempt to work out the solution on your own. Once you have a solution, or if you get stuck, unpause the video and I'm going to work through the answer to the question here on the whiteboard so you can see either where you went wrong or you can check that you evaluated this the same way that I did. So let's start out with a really simple question. And that's going to be question 1. And that question is to evaluate 9 minus 2 times 3. So go ahead and pause the video. When you come back, I'm going to work through the answer to question 1. Okay, welcome back everyone. So, question 1, 9 minus 2 times 3. Well, we have subtraction in there, we can see that. And we have a multiplication in there. So let's think to our mnemonic, PEMDAS, and we know that from PEMDAS, multiplication is going to be evaluated before subtraction. So that means we need to evaluate this multiplication first. Well, 2 times 3 gives us 6. And then evaluate the subtraction. 9 minus 6 is equal to 3. So again, because we know our order of operations, these equations become very simple to evaluate. Good work if you got the same result. Hopefully you did. If you didn't, hopefully my explanation of how we come to the answer of this question should have shown you where you went wrong. And if you're still a little bit confused, don't worry. Just go back and watch over the rest of this video again, and I'm sure that things will become more clear. So moving on, here's another question. So question 2. Again, we're going to evaluate an equation, and the equation I'd like you to evaluate is 3 times 4 divided by 2 minus 1 plus 3 minus 1. So go ahead and pause the video, and when you come back, I'm going to work through the answer to this question. Okay, welcome back everyone. So question 2, a little bit more complicated, but if we remember our order of operations, it's still very simple to work out. So let's look at the operations we have in this equation. We've got a multiply, a divide, we've got addition, and we've got subtraction. So we have 4 different operations. And if we remember our PEMDAS, we don't have parentheses and exponents, but PEMDAS does tell us that our multiplication and division is going to be evaluated before our addition and subtraction. So, because there are no parentheses telling us otherwise, we need to evaluate our multiplication and divisions first, and we need to work from left to right because we have multiple multiplication and division signs. So working from left to right, we first encounter 3 times 4, so that gives us 12. So divided by 2 minus 1 plus 3 minus 1. We then hit our divided by 2, so 12 divided by 2 is 6, minus 1 plus 3 minus 1. So that's our multiplications and divisions. Next, we need to take care of our additions and subtractions. Again, there's no parentheses telling us otherwise, so we're going to work from left to right. So the first one we encounter is our 6 minus 1. That gives us 5 plus 3 minus 1. Then we hit the plus 3, so 5 plus 3 is 8 minus 1, and that shows us that the answer is 7. So 3 times 4 divided by 2 minus 1 plus 3 minus 1 evaluates to 7. Again, well done if you got this correct. If not, I imagine perhaps the most common mistake will have been in evaluating the multiples, multiplications and divisions, or the multiple subtractions and additions. Again, these operators have the same precedence. Multiplication and division have the same precedence. Addition and subtraction have the same precedence. And thus you must work from left to right. So hopefully, me working through the answer to this question is going to demonstrate the correct method to you, and hopefully that's pointed out where you made mistakes if you did make mistakes. And if you are still a little bit confused, as with the other question, do go back and re-watch this video. So let's try one final question. I'm going to need quite a lot of whiteboard space for this one, so I'm going to bring up a new layer because it's quite a complicated question. And this is question 3. And again, we're going to evaluate an equation. And the equation I'd like you to evaluate is, open parentheses, 3 multiplied by 4, close parentheses, minus, open parentheses, 1 plus 5 minus 2, close parentheses. Now this is all one large equation, but I am going to wrap this onto 2 lines. So divided by 2 squared, divided by 2, close parentheses, multiplied by, open parentheses, 5 minus 1 plus 3 minus 1. What does that equal? So go ahead and pause the video here. When you unpause, I'm going to work through the solution to this question. Alright, welcome back. So we need to take a look at our order of operations, and if we recall, we must evaluate our parentheses first. And we have 4 different groupings using parentheses here. So what I'm going to do is I'm going to evaluate each of these individually to find the answer for each of these parentheses. I'm then going to put those numbers back into our overall equation to generate the solution. So the first parentheses we have 3 times 4. So 3 times 4, well that's nice and easy. That's 12, fantastic. Our next set of parentheses, 1 plus 5 minus 2. We have additions and subtractions. They have the same precedence as each other. That means we work from left to right. So working left to right, we hit the addition first and then the subtraction. So 1 plus 5 is 6, minus 2 is 4. Our next parenthesis is 2 squared divided by 2. Remembering PEMDAS, parentheses, exponents, multiplication and division, finally addition and subtraction. That exponent, that squared, takes precedence. So we evaluate 2 squared first and then divide by 2. So 2 squared is 4, divided by 2 is 2. And finally, 5 minus 1 plus 3 minus 1. So 5 minus 1 plus 3 minus 1. Again, we've got multiple additions and subtractions which have the same precedence, so we're going to work from left to right. So 5 minus 1 is 4, plus 3 minus 1. So 5 minus 1 is 4, plus 3 is 7, minus 1 is 6. So we have each of the parts of our various parentheses evaluated. So let's put them back into our equation. So we started out with the answer for 3 times 4, and I'm going to have to scroll down and try and fit this in. So 12. So our answer for 3 times 4 is 12. We subtract from that the next parenthesis, 1 plus 5 minus 2, which is a value of 4, so 12 minus 4. We then divide by the value of our next parentheses. 2 squared divided by 2 is 2, so divided by 2. And finally multiply by the value of our last parentheses, 6. So I can now scroll down, because we don't need to worry about the rest of the working. So 12 minus 4 divided by 2 multiplied by 6. Well, again, division and multiplication are going to be evaluated before addition and subtraction. So that means we need to evaluate 4 divided by 2 multiplied by 6 before we evaluate our subtraction. And because we have multiple multiplications and divisions, we need to work from left to right. So 4 divided by 2 is 2. So I'm actually going to write this out so you can clearly see what I'm evaluating. So 4 divided by 2 is 2, multiplied by 6 is 12. We can then put that back into our expression. So 12 minus 12 equals 0. So if I was to scroll back up, open parentheses 3 times 4, close parentheses, minus open parentheses 1 plus 5 minus 2, close parentheses, divided by open parentheses 2 squared divided by 2, close parentheses, multiplied by open parentheses 5 minus 1 plus 3 minus 1, close parentheses, which is a mouthful. All of that evaluates to the value 0. So again, once you know the order of operations, even something that is seemingly complicated is incredibly easy and therefore incredibly quick to evaluate. So just to recap, we took a look in this video at, as I bring up my layers so I can actually show you guys, we took a look at the order of operations as applies to addition, subtraction, multiplication, division, powers, roots, and parentheses. And we saw that a simple mnemonic device, which was PEMDAS, allows us to remember the order in which we evaluate those. So PEMDAS, parentheses, exponents, multiplication and division, and finally addition and subtraction. And once we know the order of operations, it's incredibly simple to evaluate any equation that's using combinations of all of these operations. So whilst the topic we covered in this video might seem incredibly basic, it is fundamentally important to pretty much everything that we do with regards to expressions and algebra. And we're going to be using a lot of algebra in this DVD. So this is incredibly important to what we're going to be looking at later in this DVD. And you'd be surprised how often you use these rules without even realizing it when you're solving equations and working with algebra, because these rules eventually become just knowledge that's in your brain. You don't even second guess them. You just use that knowledge. You will just be using it without even realizing it. So this is such fundamentally important information. And if you weren't familiar with this, you would really have a hard time being able to follow anything that is algebra related. Also, as mentioned earlier, in addition to the fact that these rules are fundamentally important to understanding and working with algebra, they also relate directly to operator precedence in programming languages such as C, C++, C#, Python, and MEL. So not only are you going to be able to understand how to work with algebra because of what we've covered in this video, but you're also going to understand how a programming language's compiler, for the most part, all languages that I've encountered certainly work this way, how they're going to take the expressions that you write in your code and evaluate those at runtime. So I hope that everything in this video made sense. I hope that you're now feeling very comfortable with order of operations, and we're going to continue looking at some of the fundamental concepts of algebra in the next video. So thanks a lot for watching, everyone.